10.6 is more angle arc theorems. We just can't get enough of these. More angle arc theorems. All right. So let's take a look at this picture. And let's say we've got this. Oh, rats. Let's do this. There we go. All right, and this is not necessarily, let's say it's not the center where the lines intersect. Okay, so we have, I wish I had a couple different colors to show you these angles. So we have some inscribed angles. Alrighty, so we've got this angle, let's call this A, X, Y, and this is B. So angle AXB, let's take a look at that one, AXB. The arc that it intercepts is arc AB. Agreed? It intercepts this arc here. Then if we look at angle, here, let's do it up here, angle AYB. Angle AYB, that intercepts arc AB as well. So guess what? If inscribed angles intercept the same arc, then the angles are congruent. So they're congruent because they intercept the same arc. So if two inscribed, I can't spell, inscribed angles intercept the same arc, then they are congruent. All right. The same goes for tangent chords as well. So let's say we've got an inscribed angle and let's see, the best way to do this would be to do a tangent like so. All right, we've got A, B, C, and let's put D out here. So angle ABC intercepts arc AC. And then angle BCD intercepts arc, here's angle BCD here, intercepts arc AC as well. So guess what? Those angles are congruent. So this works for inscribed angles as well as tangent chord angles. So I'll put a little interjection in here. Tangent chord angles. Okay. Okay, so something similar here. Let's draw another picture. Circle. Inscribed angle. Tangent and a chord. A, B, C, D. We'll call this E out here. F. Over here. Okay. Let's say that we know that arc AB is congruent to arc CD. Those two arcs are congruent. Guess what, friends? The inscribed angle and this tangent chord angle are also congruent. Or if it's two inscribed angles, it's not necessarily, maybe you don't have a tangent chord angle here, maybe you have an inscribed angle, they will be congruent. So it's very similar to this one, except for instead of saying the same arc, it'll be congruent arcs. So here we go. If two inscribed angles or tangent chord angles intercept congruent arcs, then they are congruent. Okay. All right, so let's talk really briefly about semicircles. All right, because this connects up with the inscribed angles we've been talking about. So let's say we have a circle and put a center mark on it because we're gonna need a diameter. So let's say here's our diameter, and then we're gonna do this. Draw a triangle in there. So we've got triangle A, B, C. Okay. ACB, angle ACB is an inscribed angle. It's equal to half of arc AB, correct? From last section. Well, if this is the center and AB is a diameter, the intercepted arc is actually half of the circle, isn't it? Semicircle, another term for it. So how much is this angle worth? Think about this. Or another way of asking it is, what kind of angle is it? Has to be a right angle. So any inscribed angle that intercepts a semicircle is a right angle. Helpful. You probably could have figured that out just with last section's information. Okay, here's another interesting little factoid. Isn't that a weird word, factoid? It's kind of fun to say though. All right, so here's our circle, and let's say we have, let's do a tangent-tangent angle. All right, and then this is PST, circle O. All right, so we have a tangent-tangent angle. This is the funny thing about tangent-tangent angles. This angle P plus arc TS, they're the measure of arc TS, TS not being the large arc, the major arc, but minor arc TS, that sum is going to equal 180 degrees. That's super helpful. Super helpful. So if you know that this is 130 degrees, TS is 130 degrees, how much will angle P equal? If this relationship is in place, you've got angle P plus 130 degrees equals 180. So angle P has to equal 50. See, that's kind of nice. All right, so let's do a couple of examples. Here we go. Let's do a proof, because I love proofs, and I know you do too. All right, we've got this guy here, this guy here. Did you hear the notes that the marker made? Anyway, this is circle O, L, V, S, N. And you are given circle O. You need to prove that triangle LVE is similar to triangle NSE. And you're going to prove that EV times EN equals equals EL times SE. Okay, so here we go. We are given this circle. We know that angle V is going to be congruent to angle S. Think about what we just talked about. Angle V is an inscribed angle. Here's its intercepted arc, LN. Angle S is an inscribed angle. Its intercepted arc is LN. Thus, these two angles have to be congruent, since two inscribed angles intercept the same arc. So that's congruent to that. All right, we're trying to show that triangles are similar, so we already have an A. Let's see what else we've got. Oh, hey, look at angle L is an inscribed angle, and it intercepts VS, and angle N is an inscribed angle. It also intercepts VS, so I'm just going to do it also. Angle L is congruent to angle N. We have similar triangles, thus, capital T, thus, triangle LVE is similar to triangle NSE by a similarity. And so then let's continue. We did this guy here. This is our first proof. Now let's go ahead and move on to this. Using this, just continue. So by, let's see, corresponding sides of similar triangles proportional, comma, we know that, let's see, we have to talk about EV. So E, I forgot to put E on my picture. Here's E. EV is to ES as, we need to talk about EL. EL is to EN. Therefore, EV times EN equals EL times ES by means extremes products theorem. Alrighty. So there's actually a little bit of review in that too. We haven't talked a whole lot about similar triangles or our means extremes product theorems, but that's a nice little refresher. It will show up on your final, so there you go. All right, let's do another thing. Let's do, oh, this is gonna be easy. This will make you feel really confident. Ready? We have, here's our circle. There's the center at O. And we're gonna draw in this picture. This is A, B, C. And let's say that AC, chord AC equals 40. And the radius is equal to 20.5. Find AB. So if AC is 40, here's a 40. The radius is 20.5. So from the center out is 20.5, which makes BC equal to 41. What kind of triangle is this? Here's an inscribed angle, and it's intercepting the semicircle. So here's a right angle here. So we've got a right triangle. I'll call this ABX, just so that when I use the Pythagorean theorem, I have an x squared plus 40 squared equals 41 squared. It's a family, or you can just brute force through the Pythagorean theorem. It is totally up to you, but you will find that x, or AB, let's see, x equals 9, which is the same as AB in this case. All right, last problem. We'll do another proof. So here is a circle. And here's the center. And let's draw this triangle in. And then we've got this guy here and this guy here. All right, and we'll label A, B, C, D, and this is circle O. We are given circle O, with AB tangent at B, and AB is parallel to DC. Prove angle C is congruent to angle BDC. So angle C over here is congruent to BDC. Okay, so triangle is going to become isosceles, maybe. All right, we've got parallel lines. So I'm going to mark them, label them parallel. Whenever you see parallel lines, start thinking, looking for those letters, remember? The F's, the N's, the Z's, the C's. So let's look at this guy. If we go boom, boom, boom. Okay, I've got congruent, right? So I've got angle ABD congruent to angle BDC. Angle ABD congruent to angle BDC, since if parallel lines, then alt int congruent. All right, I'm gonna mark that. There we go, congruent there. All right, now think to this section. Angle C is inscribed and it intercepts arc BD. ABD is a tangent chord angle and it intercepts arc BD. So what do we know about angle ABD and angle C? They have to be congruent since they are intercepting the same arc. So angle ABD is congruent to angle C since, all right, let's go back to the very beginning notes that we took. So here they are. If two inscribed angles intercept the same arc, then they are congruent. So let's use that. If two inscribed angles intercept the same arc, then they are congruent. Okay, we're almost there. Now we can go ahead and wrap it up. Angle C is congruent to angle BDC by the transitive property. There we go. All right, I'll see you at Zoom.